Okay. EEC 122, Electrical Power System 1. I want to give credit to UNESCO Nigeria Technical and Vocational Education Revitalization Project Phase 2 crew, the people that brought up this for National Diploma in Electrical Engineering Technology. So, I want to appreciate you for providing this material. So, I will use it to do some of my lectures. Thank you. All right. Go to chapter 1, week 1. Introduction. I want to introduce you to energy. Energy is the basic necessity for the economic development of a country because it's so important in human life. Because of electricity, our day-to-day activities are made easier, faster. Where we used to work for 8 hours, 9 to 5 in those days, we can now go there and work within maybe 8 to 12 because electricity is put into use to power robots that do the work, and also to power computers that do some other works. So work is made easier because of electricity, and the work is more productive and done faster. So electricity is so wonderful. Electricity is an energy. It's an energy. There are various forms of energy, but that of electricity is very, very useful. In fact, everything has been made better because of the use of electricity. As a matter of fact, there's a close relationship between energy used per person and the standard of living.
Your standard of living is a function of how much electricity you consume. Meaning you put electricity to work to improve your lifestyle, to make work easier, and to enjoy amenities.
Look at the diagram here. Talk about generation of electricity, transmission of electricity from place to place, then distribution within the consumers. You distribute electricity to consumers, then you see the load. The consumers properties are the load. The energy exists in different forms, only that the most important form of energy is electrical energy. The modern society is so much dependent upon the use of electrical energy because it has become part and parcel of our life. Now, the importance of electrical energy. The importance of electrical energy. Energy may be needed as heat, light, or as motive power. Energy. The advancement in science and technology has made it possible to get electrical energy from any desired form, and to also convert electrical energy to any desired or many desired form. This has given electrical energy a place of pride in modern day hold, because whatever you want to do, it's like electricity is the best for it. You need heat energy, you can get that from electricity. You need a locomotive, rotational energy on motion. Electrical energy can get that done for you. You need energy as light. You can use electrical energy and transform it to light. So it's most important, most popular. The survival of industrial undertaking and our societal structure depends primarily upon low cost and uninterrupted supply of electrical energy. When you talk about development, industrialization, all are built on electrical energy. In fact, in advanced country, you talk about economy based on the amount of energy, electrical energy they are able to produce. Electrical energy is higher to other forms of energy because of the fact that it is convenient in form. Can you see that? Convenient, easy control. Can control electrical energy very. You can step it up, step it down, can short it, insulate it. Then number 3, greater flexibility, can be converted to anything. Can even convert from one level to another, converted to AC or DC. Another reason is it is cheap. It is cheap. Then another one is it is clean. Electrical energy is clean. When you are consuming electrical energy, you don't see byproducts or products affecting the people. No. Then finally, it has higher transmission efficiency. Now let me tell you, out of this contest, practically, electrical energy is better. Number 1, you can take it from one point to the other easily than any other. For example, you want heat energy in Lagos. You are in Ilorin here. You are in Ilorin, Kwara State. You want to take the energy to Lagos. Heat energy, before you get to Lagos, you will lose it. You will lose the energy. It will cool down. You need a system to keep the heat. And you have to travel down to Lagos. Now, think about the equipment you are using to travel down to Lagos. Using to keep the heat. To keep the heat inside. That alone costs you money. Then going to Lagos every day. Let's say you have to take those things to Lagos every day. Going to Lagos every day. Imagine. It's hard. It's expensive. But when you lay a cable from here to Lagos, you spend that money. Yes, it's huge. But for years, as long as the cable is standing, you keep on sending electricity to Lagos. Instead of paying, entering a vehicle, transporting that energy to Lagos, electricity gets to Lagos. And you can step it up so that the loss is minimal. The higher you step it, the greater the efficiency. So you see now, electricity, when you get to Lagos, you convert your electricity to heat energy. Yes. You convert your electricity to motion. To motion. And any other form, like light. If you have light energy here, you cannot send it to Lagos. Let's assume there's a sun here. It's not in Lagos. Cannot send that light, but you can convert that light energy to electrical energy, then send it to Lagos. When you get to Lagos, transform it back to light energy. So electrical energy has found a position above others, and it can stand in between others and relay them together, making life comfortable. Generation of electrical energy. Actually, energy cannot be created. So when we talk about generation of electrical energy, it means you transform an energy to electrical energy. Yes. You transform. Energy cannot be created. Energy cannot be destroyed. But we can transform from one form to another. Transform. Then when you have produced energy, it has to be transmitted to where they will use it, where it is needed. Then when you get there, you can distribute. And the transfer is so fast. From Ilorin to Lagos, you want to transfer energy. The moment you switch it on here, it's there in Lagos. They have it in Lagos. Look at the distance. Very fast. This instantaneous production of electrical energy introduces technical and economical considerations unique to the electrical power industry. Let's talk about the sources of energy. Energy can only be transformed from one form to another. Now, naturally, we have sun giving us energy. That's a source of energy. The wind is another source of energy, wind energy. The water, another source of energy. Then fuel, petrol, firewood, coal, they are fuels. They are sources of energies. Then we have nuclear energy. That's another source of energy. Now let's go through them one by one. The sun is the primary source of the energy in our planet, in our solar system. The greatest source of energy in our solar system. The heat energy is radiating from there. So this heat energy can be used to raise steam and electrical energy will be produced. But there are limitations. Now, how does it happen? Can use the sun, heat up water, make the water to produce steam. The steam generates mechanical energy that will push something, prime mover, and that is transmitted to the alternator, which generates electricity. The sun can also be used to generate electrical energy by having solar panels, photoelectric materials that will trap sun energy and convert them to electrical energy. There are limitations. Number one, it requires large area of generation, even though a small amount of energy is produced. Number two, it cannot be used in cloudy days or at night. That's it. The sun will not be there in the night. When the day is cloudy, the sun will not be able to transmit its energy in a great form, in a substantial quantity to where you need it. Number three, it is an uneconomical method. Now let me tell you, this is no longer applicable. The solar panels have been developed. They have worked on them, upgraded them, and made them more efficient than ever before. So as we speak now, solar energy is everywhere. Everybody's using solar system, solar panels, solar machines, even in their cars. Many people are doing that. But the technology is not cheap anyway, but it's now possible to make it effective. Number two, wind. Yes, wind energy. Number two, wind energy. Now let's move to number two. Number two, wind energy. Another source of energy is the wind. The wind blows with great momentum. So in this case, we look for a place where we have a substantial amount of wind pressure. Then you keep turbines there, wind turbine. As the wind blows, it pushes this turbine like fan. It turns the turbine. Then the turbine, let me show you the picture here. Wind turbine. Then the mechanical energy, rotation, is transmitted to the electric generator. From here, electricity is generated. Now there are disadvantages. Number one, they have variable output. The output is not constant. It's varying. Number two, it's unreliable because you are not certain about the wind pressure. Number three, power generated with this kind of generation system is small. The power could be so small. But for the advancement in technology, there is more efficiency added now to wind energy conversion, wind energy generation of power. The next one is water. Water is another source of energy. Water is energy itself because water can be used to turn turbines. Let me show you a picture. When you put water in a container and you raise it up, when the water is coming down, it comes with force because of the force of gravity. It comes with energy, momentum. It's like it's falling heavily. This can be used connected to hydraulic turbines. It will push the turbine, and the turbine, as it moves, the shaft is connected to the generator where electricity is now generated. Or you can use tidal energy. Tidal energy, that is from the tides. The river, the seas, they have tides. The movement, the waves of the sea, ocean, can be converted also to turn turbine motion. What the water here is doing for this first one I mentioned about water, the reservoir here, is that it comes down and creates a motion. What we need is the motion to turn the turbine. Now, the motion is on the sea. That motion, the waves here and there, can be converted into a particular motion that will turn the turbine. Next one is fuels. You can further classify fuel into a solid fuel like coal, liquid fuel like oil, and gaseous fuel like gas. Yes. What do we need here? Fuel is set on fire. Anything that can support combustion is fuel. It's set on fire. Then the fire is used to boil water. You know, when water boils, the kettle will be shooting out steam. That steam is used to turn turbine, and that turbine is used to turn electric generator, and therefore electricity is generated. Okay, the next one is nuclear energy. It has been discovered that large amount of heat energy can be produced by fusion of uranium and other fissionable materials. Let me explain this with bomb. You know, atomic bomb, nuclear bomb. You know, bomb is used to destroy life and properties in the time of war. Only small ball will be thrown and it can kill 4, 5, 10 people. Can blow up a whole mansion. Then we have missiles that can be used to destroy cities. How does it happen? A small particle, maybe let's say grains, like small particles like grains of sand, maybe 2 brought together, can be used to destroy a whole building. That's a whole lot of energy produced at once. So they have also discovered how to make those particles smaller and smaller. Let me put it that way. Explaining this with that. You divide those particles into smaller particles. You grind them and you bring those tiny particles together to create energy. So you can be dropping it instead of using fuel. You are dropping it gradually, particle by particle, and it gives you energy. That energy can be converted to electrical energy, nuclear energy to electrical energy. Let me show you this picture. This is a generating station. See the containment structure. Steam is produced because of this energy. Energy is produced. Look at the red chamber, the reactor vessels. That is where they put it's like you throw bomb inside, and as it explodes, the heat is not allowed to go and kill anybody, but the heat is sent to boil water. Can you see it? When the water boils, steam is produced. The steam is let out. Look at the steam out of the structure now into the turbine. The steam blows hot and fast with violence, turning the turbine. As the turbine is turned, You know what happens? The shaft connected to the turbine and the generator make the generator to be turned. When the generator is turning, electricity is generated. It is now transmitted and distributed. This other part you see under bluish is to cool down the turbine, the steam, so that the steam cooling down to water can return to the steam generator. Then they find a way to replenish the water for steam. That is how nuclear energy conversion works. I want to show you the picture of generating station in real life. It's blur. It's generating. This is a generating station. Now, bulk electricity power is produced by special plants known as generating stations, or you can call them power plants. A generating station essentially employs a prime mover coupled to an alternator for the production of the electricity power. I'm talking about prime mover. I'm talking about steam turbine, water turbine. Yes, that can turn motion. You turn force into motion. The force of water coming down, the force of steam pushing. Those forces are converted into rotatory motion by turbines. We have wind turbine also. The same thing applies. Wind is coming with force and it's converted into rotatory motion by the help of the wind turbine, like fan, like blade, like I showed you that time. So when the turbine is turned, there will be mechanical energy, rotatory mechanical energy of the prime mover that will turn the alternator. The alternator will now generate electricity. You can see now that energy is not created. Energy has been existing in a form and now transmitted to another form. Now let me tell you energy transformation. We have chemical energy can be transformed to electrical energy. That's what we see in battery. Chemical energy. Heat energy can be transformed into mechanical energy, like you have in your generator. The petrol burns in the combustion piston, and there's a force. That force is converted into rotatory motion through the help of crankshaft shaft, and that mechanical energy is transmitted to the alternator. Then the alternator converts mechanical energy to electrical energy. Light energy to electrical energy. As we see in the case of solar panels, light is captured by the solar panel. It is converted to electrical energy through the help of photoelectric cells. We can also transform from which other energy? Okay, we have mentioned water, and we have explained how it works. So that is what energy transformation is all about, from one form to another. When electrical energy is generated, it will be transmitted through cables, wires, to places where they are needed. It could be across states or across the boundaries of countries. Yes, Nigeria transmits power to other neighboring countries like Ghana. We transmit power, we sell power to those places. When it gets to the place where they need it, they will now distribute to consumers. Okay. In modern generating station, several auxiliary equipment and instruments are used apart from prime mover, alternator combination, in order to ensure cheap, reliable, and continuous service. Now, depending on the kind of energy the power station is using or employing, We can classify power generating stations as number one, steam power station. They use steam. Hydro power station. They use water. Lift the water up like you dam, like you have Kenji Dam. The water is dammed so that it can be lifted up. The canal is full. It's filled to the brim. By the time it gets overflow, it's higher than the canal to fall, and it's falling with greater energy. That's hydropower plant. Then we have diesel power plant, where diesel is used. Like we have diesel engine. They buy diesel, put it in their engine, and start the engine for the engine to generate power. Or gas power plant, where petrol is used. Yes, gasoline can use petrol like you have in your generator. If you have it in a big size that you even sell the power, you sell the energy, you can call it a plant. Yes. Some actually use gas, liquefied gas, natural gas, petroleum gas to power their turbine. Yes, call it gas turbine. The gas is set in ablaze, so it jets out like jets. It jets out energy with force. It will push turbines, and turbine will make alternators to roll, and alternator will generate electricity power. So you can name your power plant according to the form you are using. Now we have nuclear power plant. That is not popular in Nigeria because it is expensive and it is dangerous if not properly managed. So we have nuclear power plants. We have in Nigeria, but not common. We have wind power plants, where you have wind turbine, giant turbines standing in some places so that wind in the sky can blow them heavily. We call that wind power plant. Then we have solar power plants. Like in America, you have places where you have solar panels laid on the ground. In China and in other places, they trap the energy from the sun, convert it to electricity. These are part of things we can even experiment. Then we have MHD power plants. MHD power plants. And here they use they use electrolysis. You put cathode and anode inside water, and you put some particles, maybe salt. You can dye it. You see that water begins to move from one electrode to the other, because one is positive, one is negative. So water moves like that. That may not be so efficient anyway. Now look at the picture of steam power station. Steam power station. Steam is produced by boiling water. Then when water boils and the steam comes out, it comes out with force, hot and violent. It pushes the turbines and electricity is generated. A generating station which converts heat energy of coal combustion into electrical energy is known as steam power station. Yes, you can use, in those days, coal is used to boil the water. They use it also in coal train, locomotive engines. You use coal to prepare fire, start off fire, then you boil the water. The steam produced is used to create motion. Look at this one. Yes, steam. Steam is used here. And we mentioned prime mover. It is more than that. Many things are put together in power stations. Like the labeling on this diagram. We have cooling tower, cooling water pump, pylon, unit transformer, generator, low pressure turbine, boiler, feed pump, condenser. Many of them are put together to form a plant. It's not as easy as we teach it. We just give us the basic principle. As we go higher in this class, we will learn more and more until we are able to understand almost everything that is involved in generation of power. And some of us will be having our project. We'll be having our project. You may choose, or you might be given. It might be given to you to construct a power station, a generator. All right. See you again in the next video. Thank you.